Hi, everyone, and welcome to our now regular session with Sam Savage. My name is Alex Sidorenko, and we are trying to dispel some of the most common risk management excuses and myths. Sam, do you want to tell us a little bit about the history and where we are at with the top 10 list of most common excuses?
Sure. So I'm taking us now to the Flaw of Averages .com website, which is built around my two books, The Flaw of Averages and Chanceification. And we'll zoom in on this in a second. But I worked very closely with Doug Hubbard over the years, and the two of us discovered that we were hearing the same lame excuses from people on why they couldn't quantify uncertainty. And Doug and I were responding with the same lame jokes. And I just realized, oh my gosh, we need a top 10 list for this. And so you click on the list here. And what I'm going to do now is share my screen. Let's take a look at my screen. And today, so here's the top 10 list of lame excuses for not quantifying uncertainty. And today we've made it down to number 8. We don't know the probability distribution. And I say, in the land of the blind, the one-eyed man is king. In the land of the averages, the same can be said of the man with the wrong distribution, right? And Doug says, the one distribution we know is wrong is a single point average. There are more plausible distributions regardless of shape. So with that in mind,
let's discuss it.
You can start. So yes. We don't know the distribution, so we can't use distributions, right?
I think with the first, but I wanted to start because this is such a common lame excuse that I hear all the time. I wanted to start with a clarification because people don't usually say we don't know the distribution. I mean, they say it, but what they imply is they don't know the right distribution.
Right.
Because we all know what the distributions are. Normal, log normal, PERT, Weibull, Poisson. All the distributions are known. They don't know which one is right for the particular variable. And here, the biggest lesson I've experienced in my kind of professional career as the risk manager is that definition of the right distribution changes depending on the confidence interval. Because at the 50% confidence interval, any distribution on the planet is right. At the 99% confidence interval, only some distributions may be kind of aligned with this proposal of being right. And I think the lameness of this excuse is that people blurt out the excuse before they understand, well, what's the confidence interval that they're dealing with? What's the level of accuracy the decision makers require? Because if they ever asked, they would probably discover that the stakeholders, the decision makers, are okay with relatively low confidence intervals.
Well, so let me respond in two ways. Number one, it's like horseshoes and hand grenades, close counts. Okay, that's number one. Number two, and I now want to share like how many kinds of distributions are there? Actually, an infinite number.
I'm going to screenshot this.
Yes. So and grab the URL. Okay.
Yeah.
Okay, because this is very important stuff. Okay, so this is from Professor Larry Lemus at William and Mary. And notice we got a list of 76 different kinds of distributions. Remember, that's 76 out of an infinite number of distributions. Let's not forget that, right?
Mm-hmm.
These happen to be distributions we call these the dead statistician distributions because they're only, like you mentioned, Weibull and Poisson. They're named after dead statisticians. But it's like saying there's 76 kinds of insects in the Amazon. It's like very crude, like the big ones with the yellow wings, the little red ones that bite. No, it's a very crude classification, and they're evolving faster. You could count them anyway. But notice something else here. If I pick one of these, oh, I picked that one. And then we get this lovely little, oh, it's connected to these, right? Now, if I click on one of these, click, I get a bunch of gobbledygook mathematics. All right?
Mm-hmm.
Which is very upsetting.
Yes.
And
I think we just scared half of our audience.
oh, half?
Yes, I'm being
99%.
generous.
Look, wait a second. The most common result of taking a statistics course, let's repeat it, is that you suffer from post-traumatic statistics disorder or PTSD. So no, it's horrible. And what really happened here, this was a complete revelation for me, which, by the way, revolutionized probability management, was Tom Keeland and the meta-log distribution. Now, first of all, the chart I showed you had 76 distributions, continuous. These are continuous. No, they're not all continuous, but they're univariate. Okay. And relationships they have with each other, and each one has a horrible mathematical formula, which is some limiting case and some other mathematical formula or something like that. But there were another 230 that didn't make the chart because there wasn't room for them, and that means 300 distributions. And oh no, which one will I pick? So I must confess, when Tom Keeland showed me the meta-log distribution, I said, oh no, now I have a 301st one I have to remember, right? Wrong. They're all meta-log distributions is one way of looking at it. All the continuous ones. There's only one distribution. Fit it to your data. There's the meta-log. So that is the ultimate stake in the heart of we don't know the distribution. That's one of them. The other one is, oh my God, anything is better than nothing. But we're doing a huge disservice to the managerial community to even show them this chart. You know what this chart is like? Oh, you want to learn how to drive, do you, Alex? Let me show you the repair manual for the automatic transmission in the car you're planning to buy.
Yep.
You take one look, you say, driving is not for me. And that is such an important issue. And, you know, going back to the electricity analogy. Oh, you want to light a light bulb? Oh, let me show you how Tesla's alternating current generator works. The last thing you want to know, the secret of probability management is that we let people who do understand this stuff generate the distributions and let you use them.
That's a very important point. So let me, you've mentioned, I think, 4 very important points, and let me try and kind of, summarize it for the audience. And, audience, do ask questions in the comments when you watch this. So the first very important message that I think we're trying to get across through this series of webcasts is that we believe the future of risk management is divided into 2 categories: the users of risk management and the doers, the generators of risk management. And if you're asking yourself, if you're watching this and you're asking yourself, I don't know which distribution to use, that pretty much guarantees that you are a user, and you should probably stay a user, because the generators, they know which distributions to use. That was their school, basic education. That's like statistics 101. And the fact that you don't know, it doesn't mean you have to immediately learn all the distributions. That's silly. You just have to find the people that generate it for you. So that's the point number 1, is not everyone really needs to understand which distributions better fit which data sets. The second important, very important point is when we are comparing deterministic versus stochastic, deterministic versus distributions, literally any distribution is better than a single point. That is the second important message, is that when you're moving away.
I mean, but almost any. Yeah, I mean, you're hard pressed.
Yes, yes. When you're moving from averages to a range, you're already making a huge jump towards the improving of the quality of decision making. Then the third important message is that distributions have been generated for decades, some probably centuries. For many types of variables, there are known distribution types. Log normal describes certain events, Poisson describes certain events. There are specific risk types that have a matching distribution that have been backtested and shown to improve decision making. And the kind of the tail of that important message, what Sam said, is that, and then Tom Keeling came up with a metalog, which basically says if you have sufficient historical data, or if you have any historical data, then you can actually fit. You don't actually have to rely on this rule of I'll take log normal because it's this, or I'll take PERT because it's this, or I'll take Poisson because it's this. You can actually fit a distribution to your data specifically. And I mean, I don't know whether you want to, Sam, maybe later quickly show the calculator, or maybe we'll leave it for the other webcasts later. So the third message is that you don't have to guess, because somebody already thought of that, and there are textbooks written on which distributions for which data. And if you have historical data, then Metalog is the one to go. And then the final message is the right distribution is the question of confidence. For simple problems, it's very easy because 99% of the distributions will work for you. As long as if you've chosen continuous for a continuous problem and discrete for a discrete problem, at the low confidence interval, you are set. And
you might want to add to that, okay, it can't go less than 0. All right.
Exactly. As long as you understand the very kind of basics of the nature of the data or uncertainty that you're dealing with, you have a wide selection of common distributions, most of which will do a better job than a single point estimate. But as your confidence level increases, then you have to be more specific. But then again, if your confidence level is increasing, if your shareholder is saying I want 99% confidence interval, then that automatically implies you will need to involve a generator for the task. It's not going to be a user who solves this complex task.
And if your model is nonlinear and you use the average, then you have 100% confidence that you are getting the wrong average out. I mean, you can't get more confident than that of a bad result. And that just triggered a whole bunch of thoughts at my end. One, in an earlier conversation, we may have discussed this, but I'm going to do it again. The way to explain Monte Carlo simulation. And this goes back to, by the way, let's start with garbage in, garbage out. Oh no, it's garbage in, garbage out. I have to use the right distribution. Let's dispel that myth. The way I explain Monte Carlo to naive people is, oh yeah, what's the last thing you do before you climb on a ladder to paint the side of your house? You shake the ladder. Oh, I see. You're doing a Monte Carlo simulation of the ladder, right? You're bombarding it with random forces, right? And you're determining how stable it is. Okay, here's the bad news. The distribution of forces when you shake a ladder is not the same as when you climb on a ladder. Does this mean you're going to stop shaking ladders before you climb on them because I've told you you've been using the wrong distribution for your whole life? No, of course you're going to keep shaking ladders. You learn so much from building models. Models aren't meant to give you the right answer anyway. They're meant to give you the right question. Oh my God, if we stock out, that extra inventory does us no good at all. We have to throw it away. Stuff like that.
Mm-hmm.
Okay.
It's a very good point.
Another comment. is really, well, the meta log. Let's get into it later. But I know what I was going to say, because PTSD is still our big enemy. And you're going to see down the road, oh, you know what's a log normal? Great. Then we're going to fit a meta log to a log normal, because that's easier for us to ship over the probability power grid. All right. But that will be for another discussion.
Mm-hmm.
Let's go back to the whole PTSD thing, because you're the manager, you're sitting there. You know you have to acknowledge the uncertainty, but I don't know what kind of distribution it is. Ooh, I'm thinking back to my statistics course. Oh, the PTSD is triggering, and well, I'll just use a best guess. So I want you to be able to make this move proudly. And so I want to quote from Ralph Waldo Emerson. I'd heard the quote before, I didn't realize it was him. So Emerson said, the man who knows how will always have a job. The man who knows why will always be his boss. You're the one who knows why. I need to know this distribution because I'm modeling a certain risk. The statisticians know how. The statisticians are working for you, not the other way around. Don't forget that. Stand tall and proud and lob your hand grenade and see what happens, right? And then improve your results.
That's a very good point.
So I think we have, I know we could go on for hours. We've got other excuses to get to for your next presentation. And this has been a wonderful discussion as always, Alex. And I hope that it generates interest, among both our viewers. We're both, in the same, we're
popularizing risk management.
We're fellow combatants in the war on averages. I mean, we're in the same trenches, So, okay, great. So until next time.
Thanks, Sam. Thanks, everyone watching.
Soon.